Hi everyone, this is Ashwin here. I'm going to discuss about my final year dissertation project evaluating the impact of explainable AI on transparency and predictive performance in machine learning based credit scoring supervised by Dr. Brian. Here we're going to discuss about the problem statement first. First, the credit scoring. Credit scoring is like the bank which is used for used the scoring to approve the loans or rejects the loan for the applicant. Like we can take like banks traditionally use some criteria to approve or reject the loan. So when we are using the machine learning models like random forest or XGBoost for credit scoring, to be honest, they are just predicting who is going to default. The numbers back up that. But the trouble is nobody can really explain why they are made for specific decision. And like if someone get rejected for a loan, and if someone says that's the reason, and we can't give any particular reason for rejection. So because of the GDPR and the new UUA Act says that the credit scoring counts as higher risk because it should be proper explanation to the person it affects, because the persons may apply for the loan for a particular reason, and because of the particular reason of the score, the rejection may appear because of these algorithms. So there should be some particular explainable reason. That's the problem statement we bring here, because just checking accuracy and stopping like by using explainable AI like sharp and lime, that's not enough. That's the thing we are going to do here, because we are checking reliability and how far is it, and the basically gap we want to further it. And by seeing the research objectives, our first research objective is just comparing the performance of logistic regressions against random forest and XGBoost, which is the ensemble method and neural network. But I don't want to just say this is one bigger, because actually I ran a significant test like D-long test to check if the difference is real or just a noise. And if we see the research objective too, like where the explainability side, like I used both sharp and lime to see which models actually biasing its decision, because whether the matches what you expect from a credit risk theory. Because if you see the research objective C3 as well, probably the trickiest one for me, because I wanted to know that the explanations themselves are stable. Because this took me a while to realize if we are re-explaining the same model twice, you will of course you will get the same answer. That's not the proof anything. Like if you are arguing the same thing again and again, so when you are arguing the same thing again and again, it won't be become a true. That's the same thing. Like when we are retraining the same model again and again, it will give the same output again and again, so it won't be a correct one. So I came to conclusion that, so in the research objective 4, last one is like fairness check. Basically, even if the model is accurate and explainable, and it's quietly treating some groups unfairly, like based on race, based on the community, or based on religious. So this is the research objectives of 4. And is our methodology we are going to discuss. Because if we see the pipeline architecture, we can say it can be segregated into two types. Like and second one is see the data pipeline. The first step is like we are data ingestion. Like we are taking care like two data set, German credit data set, lending club data set. If we take the German credit data set for a benchmark data set and lending club data set for a generalization, because it has a large number of data. And then we are performing the feature renaming and data selection, which comes under data pre-processing, and same as exploratory data analysis. Because before we are moving to any data we are going to handle, we have to first explore the data, how the columns, how many rows, and what are the features we are going to consider, and what are the features we are going to omit, and we have to find the missing values as well. And based on the missing values, we have to handle those missing values. So these are the basic steps we have to perform, and then pre-processing, that is encoding and outliers. Outliers is like a bearing the anomaly values, and smart make for handling the undersampling, and we are splitting the data set into training, validation, and testing split, and then we are moving for a validation pipeline. The validation pipeline, we are performing champion contender model training, which is logistic regression, random forest, XGBoost, neural network, and we are going to with grid search CV, and we are going to compare the performance evaluation of like ROAUC, cost sensitive metric, and D-long test to find the difference. And if we see a sharp global and local explanation as well. And for Lime, we have only local explanation, and we are performing a stability analysis with the model to understand the cross seed as well. And also we are doing the fairness audit, like fairness audit in the sense like we are doing with the demographic parity. Here demographic parity is like we are equalizing the odds, and we are done with the fairness audit. Then we are performing like we are integrating the module, like integrating the module. We are first we have run the module 1, which is a German credit, and in module 2, which we have run this learning, we have recorded all the outputs, and we have created the outputs, and we are discussing all the output, and we are telling how the model is performing with the different data sets. Because German credit data set is based on German, and lending club data set is based on the US. So we are discussing those stuff in the integration module. And if we see the data set here, I earlier of German credit data set and lending data set, the two data sets actually which we are using. And the German credit data set is too small because it has only classification with the 20 attributes, and which is based on a journey, and it's happened in the year of 1994. And if you see the lending club data set here, it's more than 1 million rows, and it has between 2007 to 18 United States. So we have decided to proceed further with the project by choosing a German credit dataset as a benchmark and lending club dataset as a generalization. Because the same pipeline which we have applying for a German credit dataset, we are applying for lending club dataset as well. Because as we said earlier, we are going to evaluate the fairness and transparency. We can't come to the conclusion with handling with the one data set with a particular region. So that's the reason we have to selected with the multiple data, like a multiple data set, like one from a German and from one from the US, and with the different year variations. So we can have some conclusion with this. And if you see the champion contender model, let's see, like champion contender model itself, we can understand that we are going to compare the logistic regression as a champ. We are considering the logistic regression as a champion, and we are comparing all the models with the logistic regression. Like all the model in the sense, all the fancy models, like fancy model in the sense like random forest supervised machine learning model, which we have used here, and XGBoost is an ensemble method. Ensemble method is like integrating the a machine learning model is called ensemble method. And here we have used the XGBoost and neural network. And neural network is deep learning method, and which we have contenders, and which we have a higher accuracy. Equally, we can say that interpretability. And I tuned all the model in the four-way, like four models in the same way, like same grid search CV, and all the setup is same for all the models with all the data sets. So with the same treatment, there is no changes for anyone. So I compare the contender back with the champion, and I performed a D-long test as well, because D-long test is we have used it because all the models showing not much different statistical difference. So that's the reason we have used the D-long test. That's we are going to discuss further with the performance evaluations in the research objectives. So yeah, as I said you before earlier, like if we see the performance matrix, performance results in research objective 1, like contenders to win random forest with 0.79 in German credit, and XGBoost with 0.71 on lending club both. But i I came to conclusion like D-long test on those differences, and none of them came back with statistically significant. So technically I can actually claim that fancier models are doing better, not in a way I could defend statistically. And honestly, to be I surprised that the most was the I would defend statistically. And honestly, that I surprised most was the gap between four models gets smaller as the data set gets bigger. And one of the smallest German credit data set spread was 0.08 AUC, and the hundreds of millions rows lending club data set is dropped to the 0.06. That's basically more data through its less reasons. So next we are going to see explainability. Explainability, as we said, we are using a sharp and lime. For explainability, I deliberately used two methods. That's completely different. Like sharp is exact deterministic because it's based on a game based theory, and lime does not something, it's different, it's not a deterministic. Like if we say the local model around it, for example, I used both. If the two methods that work nothing like they still agree on something, that's much strong signal. Then either one of it still won't, right? So and then they did not agree on the big picture. That's the reason both data set point financial capacity features as the most thing, the checking of account of the status of German credit and the interest rate and the loan term and the lending club and the actual number of the features both agreed and independently grew from 3 to 6 once I moved to bigger data set. And if we see the research objective 3, that is the explanation stability. In the explanation stability, the slide probably the part 1. Like a part I am most proud of them, I am honest. Because the whole point is explanation, the whole point is an explanation is useless. Because it changes every time you ask for it. Sharp come back with the perfect stable correlation of 1. Not just rerunning the same model again and again. But even when I retrained all the models completely from the scratch of different data, Lime does not hold anywhere as well, somewhere between 0.20 and 0.36, which is very, very below. What you want to know here is if we are going with the rely on something with the regulatory decision, and here's a bit I want to expecting a sharp stability actually go better with the data set, it's going bigger. Going from 0.95 is no matter. With the nearly 0.9 and with the Lime, don't improve it at all. So tell me, Lime, instability is not a data problem. You can just fix with the rows. It's baked how method we are implementing and we are working for it. And if we see the fairness audit here, fairness audit, if we see with the graph I have generated with the bar chart, fairness was the important thing, the most carefully. The reassuring part is like the protected attributes don't rank highly with the sharp importance in either data set. The model seems to be driven mostly with the financial factors, not demographic. But lending club base, I can find something with the legitimate risk factors alone. But it ends up with the house ownership status, which exhibit with the financial situation as well. But on German credit, I actually could not say much because it is comparable with the small and we can conclude with this, which is honestly exactly. So I wanted to check this again with the proper scale. So the big takeaway me here is the bigger model explainable does not mean it's automatically fair. That's something you have to keep checking separately. And cross data set integration. So if we see the cross data set integration, as I said you earlier, we are going to record the values of the module 1 and module 2, and we are going to integrate the module 1 and module 2, and we are going to discuss those outputs, like we are comparing the models of the performance, like with the normalized values and with the thing, like ROC, AUC comparison and operational cost comparison as I shown here in this chart. Because here we are comparing, as I said you earlier, the regression is compared with the fancy one with the both German and lending club dataset to understand how good they are performing. And based on the results and finding, I can say that the interpretable model helps its own statistically against every fancier model on both the data set. Because the cost of choosing interpretability is small, and it's even yet the smaller one because of the scale. Got more stable with the line, either don't those things. And the fairness check also turned up with the real and measure gap. And I'm glad to say that the whole pipeline actually run end to end and successfully to completely and independent on real data sets as well. Also, if we see, this is our module 1 German credit data set, which we have run the model. And as I said you, this is the benchmark study. And these are research objectives, which I explained here as well. And the pipeline which we are following here is like we are first installing the data sets, and we are moving with the importing and global settings. And once we're done with this, and we are doing the loading with the German credit data set. And once it's loaded, as I said you in the flow chart, it's a future renaming, and future renaming is done EDA. And if you see, once the data is explored, and then we are training with the champion contender model training with the grid search CV. As I said you, all the models were trained with the same procedure without changing anything. The same thing, if you see the neural network architecture search with the contender 3, like as I said you, like we have taken 1 to 3 neurons with the different sizes. That's the thing, like 1 layer to 3 layer with the difference is 64, 128, 32. And if we see here like performance evaluation with all 4 models of research objectives, we can see here with this one. And if you see the ROC and confusion matrices as well, and D-long statistical test, because as we said earlier, because of the AUC is similar in the lending club, so we can't come with the AUC test alone score. That's the reason we have find the thing of D-long test. And if we see the model comparison, like which model is best among this in the German credit data set as well, and the solution for that, and SHAP water research objectives, and if you see the Lime local explanation, and these are the stuffs in the German credit data set. And if you see similarly, it's in the module 2, which is our learning club data set as well. The same pipeline which we are following, the similarly, first we are installing and we are loading the packages and feature selection, pre-processing, EDA, as I said you, the data set is split into three: train, validation, testing split, cross data set feature, model training, stats model, robustness checking, feature, neural network architecture, and we are performancing the evaluation, and model leaderboard, classification report, visualization confusion matrix, ROC, D-long, sharp line limitation, sharp waterfall, everything is same and same. Sharp cross stability, everything is same. So that's the reason. And if we see, as I said you early, integration module. This is the integration module where we have taken the output from the recorder of module 1 and module 2, and we have, if you see the one, we have recorded the values, and we have once they recorded the values here like this from the output we got in the previous modules, and we have uploaded those stuff here, and we have generated these charts, and we are explaining this stuff with the discussions of both the models, like which model is performing how, and with the which data set how it's performing here in this integration module. The challenges with whatever I face here is, like, the worth mentioning is on yearly, with my sharp stability test, I just re-explaining the same fixed model over and over and over, which my supervisor pointed out and just asked me to fix it, like, don't actually prove anything. Of course it's stable, it's the same model, so I had to go back and retrain independently, resample with the data, and testing the robustness properly. And I also had a threshold leakage issues, like I was picking up a decision threshold with the testing and it with the same data, which is a bit noisy mistake. Like fix it with the proper three-way split, and then I have came across these issues. Then if we see the random forest sharp rankings were jumpings between seeds, until I limited how the trees will could go. Also, if you see TensorFlow 2.20, don't play nicely with the Keras tuner, because that's the reason I ended with the manual search instead. And I also, if you see the lending club data set is like 1.6 gigabytes, so I had to look it into chunks, collapse, just gave up. So that's the reason we have making the data set into a multiple chunks here, like we are have in the collab to access it, because in the collab also we have some delimitations like the memory capacity and the consumption, so we have to manage and manipulate and everything. That's the reason. And if we see in the slide 14, the future enhancement, in future enhancements there is a thing like getting a hold of actual verified protected attributes and the fairness of the audit of just preliminary, and applying sharp to the neural network too. Since right now the one model I have not properly explained, testing is testing pattern on the third data set just be like an extra thing, but the two data set it's not be a coincidence. Looking into threshold, the balance, fairness, and the cost together rather than after each other. And eventually, if you see, turning this into actual toolkit, lenders could use document compilants under the UEA Act. And if you see in the conclusion in the next slide, like I would say interpretable model is genuinely defensible choice in credit scoring, not something you very settle. Also, if you see Sharp holds up a very well enough for regulatory use, Lime really does not get better with more data. Fairness is not check something you get free just by using it with the more data, because fairness is something you will get with just by using the explainable model. You have to keep checking it, and also help us to across two different data sets which was given to across the two different data sets, which what gives the most confidence in it. And also I want to thank my professor and supervisor Dr. Brain for giving me this opportunity to work on this project. And thank you, really thank you so much for motivating me endless and giving me a support uh, by the feedbacks and the follow up on each and every week.